Hi, everybody. I'm Derek Runberg from SparkFun Electronics.
I'm Shelby Landsman from SparkFun Electronics too.
And we're here to talk about the Microbit ecosystem as a follow-up to the roadshow that we just completed in 4 different places, right?
Yeah.
4 different stops.
Yeah.
So if you're on, welcome. We're going to talk through a couple of different things in terms of both the ecosystem in terms of products and what we've seen in the classroom and what we offer at SparkFun to help you out, figure that out in the classroom. So, with much ado, I think we'll move to the slides here.
I'll try.
Hello.
We should be able to hear you now.
Okay, perfect. You can hear us now. Sorry about that. We will back up.
Technology.
We're a technology company, I promise.
So those of you that are just joining us, and those of you who have been on, sorry about that technical difficulty. I'm Shelby with SparkFun. This is Derek. We are going to talk a little bit about the Microbit, what we're going to learn today, just kind of go over it.
And if you need to get a hold of us, here's our contact information, both our email address and where you can get a hold of us via phone, and the favorite things that we like to talk about.
Awesome. So thanks again for joining us today. Sorry if you guys have already heard a little bit of this, but some of our goals for today are to introduce you guys to the Microbit. Hopefully you have done a little bit of research, maybe not, maybe you have some Microbits learning or teaching in your classroom right now. Here's are some ideas that we can talk to you about implementing them in your classroom, district, that sort of thing. We're also going to talk about how SparkFun can help you via our ecosystem, consulting, professional development. We are here to help you as educators. So the Microbit is a pocket-sized computer. It's very tiny. It's very cute. And it really brings computational thinking to life in the classroom via coding, data visualization, and things like that.
And it being physical computing. So it gets programming something off of my screen and to something that is tangible and useful for my students.
So it is embraced globally. It first came out in the UK and Denmark. They gave each year 6 student one of these pocket-sized computers. It's now being embraced nationally in the US, as well as up in Canada. So it's making its way across the US and internationally as well. So following the year 6 implementation, they posted a survey to all the students using the Microbit in the classroom. And these are kind of the statistics that they came up with. So 90% of the students thought that anyone could actually code after using the Microbit. 86% of students thought that computer science was actually more interesting and fun. And 70% thought that more girls would actually choose this to do in the classroom or for future. It also boosted teacher confidence quite a bit.
A brief history of the Microbit. Way back in the 80s, the BBC was a big proponent of getting personal computing in the classroom with the BBC Micro, which was one of the first, you could say, PCs of history. And that ended up being about 1 in the classroom. It looked like an Apple II or Apple IIe for the most part. And then as part of the Make It Digital initiative, a number of other computers have come out since then. One of them, many of you may know, the Raspberry Pi came out in a very similar fashion. And the newest one has been the Microbit itself. It's a big partnership initiative of both developers, educators, hardware companies. So Microsoft being one of them, the BBC being a big proponent of it, Samsung, as well as a number of others. And then beyond that core partnership is a number of ecosystem partners as well, that SparkFun is one of them. Since then, it's just really taken over, especially here at SparkFun, it's taken over. It's one of our major products that we carry for education and that we talk about the most.
So we're going to go over some benefits around using the Microbit. The top benefit that we see a lot, especially in education, is that there's no software installation. And this is actually compatible with your Chromebooks. So we know that many schools are actually using Chromebooks and find some challenges using some other hardware and stuff like that. So this is Chromebook compatible. It's also compatible with Macs and Windows. So if you are using those iPads, it is compatible. So it's really easily accessible in the classroom with current hardware that you guys have. The price point is about $16.50 just to get started. So whether you're doing 2-to-1, 1-to-1, this is a really easy board to get students started and at a pretty easy price point. It's also pretty scalable in terms of applications, whether you want to go into robotics, data visualization, engineering, circuit building. There's so many different directions you can go in. So here at SparkFun, we offer a lot of different services. So not only are we a hardware provider, but we also provide ongoing consultation. We provide professional development. We have curriculum offerings. And we want to support schools. We want to support you guys. We know that this is an investment of not only time, but money. And we want to make it successful for you in your district, school, program, whatever you're a part of. So we'll touch on these products in a few minutes here, but this is kind of the scale that we see within SparkFun's continuum and microbit ecosystem. So not only is the microbit programmable with a block-based coding called MakeCode, it's also compatible with writing in JavaScript and advancing into Python. So you can really scale your languages throughout the grades. With that, you can also scale products, different boards, things like that. So many times they'll just start with the board, but then from there they add on sensors, they add on different things with how they want to kind of progress their ecosystem.
And with this model, we give a ballpark for grades. You know your students best. So even though we have MakeCode starting in 3rd grade, you may feel more comfortable starting it in 4th grade or 5th grade, depending on your students and kind of their experience with computer science up to this point. You can see down at the bottom the skill level progression, which aligns to those grades. So even if I'm a high school teacher just starting my student in the microbit, you can still be using just the microbit board itself. This is not a 3rd grade product. It's just that that's where they're starting, and so you can meet your students where they need to be rather than a grade specific product. So some of the hardware that we offer an ecosystem of different products around this in the form of carrier boards. And you'll see a number of them today, both in terms of expansion kits, but we also sell the boards by themselves. So if you want to build your own robot and not use our chassis, or you already have maybe a robotics chassis, but you just want to program it with the microbit, you can buy the RoboBit by itself. And we're also going to show off a number of Gator tools as well today, a little bit of a preview of some upcoming products. But we just wanted to show you the scale of starting from the microbit itself all the way up to doing some pretty technically competent things in very specific application points. So with that, professional development and training. We all want to know what we're doing in the classroom. We all want to feel comfortable in the classroom. And what are some of those pitfalls? How do we get started? And so we offer professional development and training in many forms. You might have been at a workshop of ours in the past. You might have taken our microcontrollers for educators course here in Colorado. You may have seen us at ISTE. We do a number of outreach events, but we can also come to your district and give a professional development there as well. So we do a number of different things, ongoing support as well, and a number of different models, and consulting. So if you're just in a school district where you're excited about getting going, and how do I get this in the classroom because it's such a useful tool, we offer custom consulting as well. So we help you get started. And then really this year is a new week-long workshop that we're offering. It's Microbit for Educators, which is actually being hosted up in Portland, Oregon at the Oregon Episcopal School, July 22nd through the 26th. So if you really want to learn more, dive in deep into this whole ecosystem and bring back at least a full set, not a classroom set, but a full set for you to start playing with and figure out how to do this in the classroom, that workshop would be best for you. Come and join me in Portland for the summer, or at least a week of it.
So with our hardware, we like to make sure that classrooms and people can just get started with what you have and what you've purchased. So SparkFun offers a wide range of these, whether it's curriculum, whether it's guides, things like that. But all of our hardware will come with guides. So getting started guides, how to get started, that sort of thing. Experiment guides, so it'll walk you through all the hardware within the kit and how to kind of set that up and play around with it. And also hookup guides. There's a ton of videos out there, Microbit series, concepts, how to do this, as well as how to do the software installation. But with this product specifically, obviously there isn't one. But we want to be able to support you and make sure you have everything resource-wise just to get started.
With that, we're going to pause, and we're going to pause for any questions that people have. I'm getting a head shake of no, we don't have any. But one of the things that we do want to do is show off some of the ecosystem hardware and products that we do have, so that you can see that they're real, that we're not faking anything. First off, I wanted to give you.
Oh, sorry about that.
I want to give you a scale of the size of this thing. So this is the Microbit. And it has the world's worst monitor on it as a computer. So it's 25 total pixels, not 25 megapixels. It's 25 pixels total. 2 buttons, A to B button, and a number of other things are on the back. So all the scary electronics are on the back. But it's chock full of different sensors and things like that for students to get started with. But from there, we have a number of different ecosystem carrier boards that you can choose from. And I have a few of them here in front of me, and we'll show them off. This is our Gamer Bit. And all of our carrier boards have these edge connectors, which allows me to take the Microbit and plug it in like that. And now it turns my Microbit into a game controller. And I can use this to make some really simple basic games. But I can also do something like control a robot. Right here. So this is the MotoBit, or the Microbot, and the MotoBit controller. You can see that it already has a Microbit attached to it. And this is our shadow chassis. So it's our standard SparkFun tabletop robotics chassis. And it all comes in a kit, snaps together. And I can program the robot, control it with Microbit alone, or if I had another Microbit, I can use it to remote control the robot.
Derek, how can you control this with that?
So the Microbit has a radio on it. So I can actually connect my Microbit and have it talk to other Microbits in the room across wireless via radio. And it's actually really fun. We've done this with up to 300 Microbits in a room at a conference one time. Worked just fine. So if you're wondering, well, maybe how many of these can we have in a room at one time? Not that you would ever do that, but 300 at one time. So that's both the Gamer Bit and the MotoBit. The Gamer Bit comes in a kit that allows you to expand. The arcade one here. Expand the controller to something a little bit more fun. Right, so now I have a joystick instead of the buttons, and I have an A and B button that I can use as arcade buttons as well. So it gives me a number of options there. Cardboard robot. Something that I just built today. So I was wondering, like, what does it look like to, if I don't have a shadow chassis, what does that look like in terms of robotics? And this is just a really basic robot. I call it the 10-minute bot. And it's a cardboard chassis robot with the motors and wheels and the MotoBit, battery pack. So I can just drive this thing around. Students can build this themselves and modify it however they want. So if they want to have flames coming out the backside, they can, as long as they're cardboard flames and not real flames.
Many times, or a lot of questions that I get is how can I incorporate my 3D printing more in the classroom? This is an awesome example of that. So you can have students design their own chassis, create their own robots, give them competitions, things like that. So it's another way to incorporate maybe some hardware that you already have and that's sitting around to expand that into your Microbit ecosystem.
Our last topic kit is our weather station kit. We call it the Microclimate Kit, and it's around the weather bit. So So this is a sensor board, carrier board that has a slew of weather sensors on it. You can track humidity, temperature, barometric pressure with it, as well as soil moisture and soil temperature. And then there's breakouts for the anemometer and wind direction and rain gauge. So you can build a whole weather station and track the temperature and see whether it's time to plant your garden or not, which is pretty fun. In terms of the next set of ecosystems, Shelby, why don't you tell us about this?
Yeah, let me just get this weather station
Out of the way.
out of the way here. So this is our Gator Bit. So we have this awesome Gator Bit. I'm going to pull out my Gator Bit somewhere else here. But the cool thing about this microbit is that it has a bunch of little pins at the bottom, as you guys can see, but they're teeny tiny and require soldering most of the time. So with the Gator Bit, this actually breaks out every single one of these pins on the board here. So again, it just clips in. And as you can see, you can just alligator clip all of these different sensors through the Gator Bit. So right now, we have a bunch of ProtoSnap Gator Bits, whether it's buttons, lights, temperature, things like that. You simply just take an alligator clip it from the Gator Bit to the ProtoSnap Gators. But what's super exciting is that we actually have 6 new Gator Bits coming out around August.
And I broke the rules and snagged them off somebody's desk. So if I get in trouble, I'm sorry.
But the awesome thing about these new Gator Bits coming out is that they are from an NSF grant that we are working on with bringing computational thinking to science classrooms. So they are all around physical science. So there's soil moisture, there is
here, you can actually show them the real product, right? So there's the Gator sound. So it's a sound detector. There is, why don't you show them that one?
I'm going to say this one.
Okay, fine. Gator particle. It looks at the particulate in the air. It's also actually, a lot of people know what this sensor is. It's the same thing that if you put your finger on top of your cell phone for your pulse, it works as a pulse ox sensor. The next one is the Gator UV. So it's a UV light sensor. So whether you can get a sunburn or not, or just a wonderful golden tan. The next one is Gator air quality sensor. And a soil moisture sensor. The 2 prongs, just stick it in the ground, and then it will change values based on how moist the soil is. And last but not least,
this is my favorite sensor coming out. This is called the Gator Log. And what this actually can do now is it can collect data in real time. So there's a real-time clock on here, as well as a micro SD card. So you can get that data in real time, and you can start actually analyzing that data. So we're really excited about this new line coming out because you can actually bring this more into your core classes like science and math. Instead of just using it in electives or after-school programs, you can teach real concepts and standards in the classroom.
Yeah, and be able to actually correlate a specific data point to a very accurate time. So it was 32 degrees outside at 6 a.m. this morning, rather than kind of fudge and kind of guess. So that's a wonder of a real-time clock, is that I can correlate something that happened with the exact time and get some really good quality data to be able to work with my students with.
So that's kind of the extent of our line currently. I want to just open it up to anyone. Are there any questions, or feel free to type in some questions that you guys may have just come up with. We're just going to pause and chit chat otherwise, so feel free to send your questions, otherwise we might bore you with.
Yeah, go ahead and read it up. So the question was, is there another display for, other than the 5x5 LED array? Currently with SparkFun, we do not have a different display, but that is definitely a good idea. There is a number of things. So we have a serial LCD that's not necessarily designed for games, but you could get that hooked up with UART and communicating serial via the microbit. But in terms of a different display for games, no. Not at this time. Question was, would the Gator boards handle essentially what you would normally do with other probeware companies such as Vernier? You can get a number of the same data points. The Vernier stuff is very high quality sensors, and so are the Gator boards themselves. Just they're going to be in a different form factor. So if I'm trying to get the temperature of liquid, for example, these don't have the actual probe that I can stick into the liquid, but they are all essentially the same sensors, just not necessarily going to be able to plug it into Vernier's software. No price points yet. Do we? I don't think we do.
We have a rough estimate. It's still going through catalog right now, but if whoever asked that question wants to reach out to us directly, we can talk about pricing and kind of what that looks like.
In terms of the week-long course? Oh, the question was, will there be any PD on the East Coast? We currently don't have anything scheduled in terms of that, but we would, feel free to reach out, and we'd be more than happy to schedule something with you in the district.
Derek is also going to be at ISTE this year, which is at the end of June. So if any of you teachers are heading to ISTE, he'd be happy to meet with you guys there and kind of go over some things. I'm not sure if you can accommodate training, but can kind of get you started with some ideas at least.
Buy a cup of coffee and talk about technology. That's my job. Drink coffee, talk technology. So can the Microbit be programmed with Scratch? There is a Scratch implementation that uses the Scratch plugin, so it can. There is limited functionality with it in terms of being able to use some basic inputs and outputs. It does, I believe, require Bluetooth, though, at the same time, and so if your laptop doesn't have Bluetooth, that is not going to be an option for you.
So this question is, what do professional development costs look like? It's kind of a range. We do a day. We always kind of recommend 2 days of training, just because your teachers will walk in on day one and be super excited and not really retain that information that we just went over. So then that second day is really used to kind of talk about classroom implementation, best practices, and kind of go over what you've learned that first day. So there are some fees associated with that. We also do consulting hours. So we can, whoever posed that question, please feel free to reach out to us directly. We can talk about what that looks like for us to either come to your district or do something remote.
Sorry? Oh, the question was, if I've been working with this and I get stuck, can I reach out to you directly? Feel free to reach out to me. Email is best with me. But yeah, you can feel free to reach out.
These are awesome questions, everybody. Please type them in. Don't be afraid.
Perfect. So I think we're going to go back to the slides for a bit here, and then we'll kind of get over a little bit more detail, because I know that we missed some hardware, but we have pictures of it. Okay. So the continuum again, just that you now have some idea of the products that kind of go along with those different skill levels and implementations. We talked a little bit about the Gator Bit and being able to hook up with alligator clips sensors. So this is primarily designed for younger students who really don't have the dexterity to handle a breadboard. What we're also finding is that a lot of science classrooms, when we want to implement this in a science class, we don't want to spend an entire week hooking up things on a breadboard or learning how to use a breadboard to get temperature data. But what we can do is hook up a couple of wires with alligator clips and get temperature sensor pretty quickly and pretty accurately. And so when I want a piece of data quickly, I actually reach for alligator clips and just be able to clip these things together. If I'm in a tech ed class where part of the learning outcomes are knowing how to build a circuit and use a breadboard and prototype something, then another kit might be a different option. You saw the Moto Bit and the Microbot kit already. Wanted to give you a close-up view of it. The Moto Bit can control 2 motors as well as a number of servos, and we can add sensors to it, so bump sensors, line following sensors, things like that. You can see actually with the robot itself, it comes with 3 line following sensors, so you can start to do some basic PID loops and logic based on following a line and things like that in the classroom. The weather bit up close and all of the parts that come along with the kit. I actually currently have one of these in my garden right now, monitoring the soil temperature so I know when I'm supposed to plant my lettuce.
A cool application that we're seeing a lot of with this weather bit is it actually being hosted in the library at a school. And each grade is coming in and doing different things with it. So whether it's analyzing the data that it's pulling or talking about different weather patterns or different clouds even. This is kind of a really nice thing for a maker space or a centralized location that kind of brings the school together and in different ways of using it.
There's also an interesting implementation with this is that just having the weather bit itself, just the board, and tethering it to like a 3-foot party balloon with helium and having it tethered so you're not releasing this into the wild, and then letting the balloon out, let's say 100 feet. You can start to collect data at what does it look like, what does the temperature look like 100 feet up from the ground, what does the humidity look like, and we can start to track some of those atmospheric data points at different elevations. So you're starting to look at weather and microclimates, not only different locations on the ground, but also up in the air. Gamer Bit up close. Again, we like using it as a controller for our robots. But again, I think adding this to some of the things is Scratch hopefully becomes more and more open to different inputs. This could easily be a game controller for Scratch. Or if you made really a small basic game on the Microbit itself, it's pretty fun. Last but not least, this is the kit we didn't have in front of us for some reason. We apologize for that. But this is the Microbit SIK. So this is our Inventor Kit. Many of you already know about the SparkFun Inventors Kit around our red board. This is the same quality and in-depth electronics kit that you've come to know and love from SparkFun, but for the Microbit itself. So it includes the Microbit, battery pack, all the components you see there. It includes 11 circuit experiment guide as well, digital guide. So both in MakeCode and Python.
Yeah.
You're going to talk about the
Sure. So we do sell lab packs as well because we know that schools oftentimes like to purchase 10 or 20 for a classroom. So we do sell kits of 10 of most of these products. The nice thing about the lab pack is that it actually comes with some refill packs too, because things mysteriously go missing in the classroom or accidentally break. We get that. So with this, it comes with extra, LEDs, little sensors, things like that go missing every once in a while.
And batteries included with the lab pack. So we give you the batteries for them as well.
Yep. And the price point is actually better to go with the lab packs if you guys are curious.
Over the past year, we've worked with a number of partner school districts in a number of different implementation models, what this looks like. I work remotely up in Portland, Oregon, and we've worked very closely with Beaverton School District over the past year through their innovation program. And one of the things is that they looked at an implementation of getting every 4th grader and every 5th grader, 6th grader, and 7th grader working with the Microbit. So they're looking at a 2-to-1, 2 students to 1 Microbit implementation. It's starting at the younger ages in the Gator Bit and Gator boards at 4th and 5th grade, and then the Inventor's Kit at 6th and 7th grade. And the way that we've worked with this is in terms of a custom partnership package is that we've, since I'm on site, done a lot of professional development, co-development in terms of curriculum and how do I implement this across the curriculum. So Beaverton was looking for how do we do this in our social studies classes? How do we do this in our science classes? How do we do it in math? How do we even do it in PE? And so really exploring different curricular opportunities to bring in computer science in the microbit, and then continuing support around that. So being able to push into the classroom and observe and give teachers feedback on things.
Another cool story about Beaverton too, as they're trying to do this throughout every single classroom. They had an English teacher that actually wanted to participate in this implementation, and how they're doing it is they're reading a book in English with a girl who has cerebral palsy. So their final project is to actually make something that can help this girl. So there's so many different ways that you can do this, whether it's science, whether it is PE, but also in English. So there's different ways to kind of think outside of the box and bring this into different classes. Another story that we love to touch on is Adams. They are a local district to Denver, Adams 12 5-star schools. This is kind of a different story. So they came to us saying, we've done a ton of research and we want to use the microbit. We're not quite sure how to use it, but we want to meet these standards. So that was kind of a new challenge proposed to us on, well, here are the standards, here's the product, what can we do? So this was an entirely new implementation around our Microbit Educator Lab Pack, which is another part of the ecosystem. It comes with some boards and just a few sensors to get started. So this, we did a lot of consulting with Adams and really figured out what sensors worked best for them, how this looked implementing in their classroom. They had some teachers who were kind of terrified. So really working one-on-one with those teachers to make sure that implementing in their classroom went smoothly, they were comfortable, they were confident, and they knew that they maybe wouldn't have all the answers. So just being able to help walk them through, it's okay if you don't have the answer, we'll help you, or we'll help you figure it out, or to just challenge your students and see if they can come up with the answer. So this is a really cool implementation going on at a district local to us.
And it's really been fun to work with them too, because they've really known what they want, but they also like, how do we teach specific things, or how do we make this interesting, give context to those very sometimes difficult to teach concepts. And so it's been really fun to both listen and learn, but also be able to give maybe a different perspective on things. As a previous educator, it's always fun to talk teacher.
Totally. So we talked a little bit about this at the beginning, but currently we are working on a National Science Foundation, or an NSF grant, with CU Boulder, as well as Denver Public Schools. And they're using the microbit right now to bring computational thinking and data visualization to life in the classroom. So year one started out with just the microbit, and now they've actually moved into the Gator Bit and have really helped us develop this next set of Gator sensors that are coming out. So the cool thing with this project is that they're using next generation science standards and proposing phenomena to help bring real life situations to life and solve problems. So, they're collecting data in their school and figuring out, why is this corner so much hotter than the rest of the school? Or why does it stink in this hallway? And what can we do about it? So they're getting that data and analyzing it, but then they're also coming up with the solutions to help solve that in their own schools and presenting it to district admin, teachers, things like that. So it's kind of that full creation of an actual real life problem and solving it using computational thinking. Another quick implementation that we're working with is Chandler Unified School Districts. They are down in Arizona. They came to us wanting to do a robotics implementation. So we know that robotics are super fun. It's really popular, and there's so much you can do with it. So They had students using the Microbit already, so they really wanted to kind of use that platform. They then have students go into using the Inventor's Kit, so really figuring out the engineering portion of that, and then moving into the Microbot Kit. So with that, they're creating different obstacles and courses via engineering and implementing their robotics to create courses, solve those courses, solve problems, things like that. So as you can see, we just went through 4 different implementations, and all of them are different. All of them wanted different things. Each individual school had different goals. So it just kind of shows you that you don't have to pick a package out of a box and say, you know, here you are, this is what you get, you're stuck with it. You really can customize this to what you want in your district.
We're going to pause really quickly for any other questions. We have a few. Scratch with Microbit. I think so. I have to look it up. We might be able to answer this later on in the comments, but I think if your Chromebook has Bluetooth on it, it should work. I know that you have to install a Scratch plugin for your computer, so I think it might only be Windows or Mac, but I need to double check on that. So what's the distance between 2 microbits when I'm using the radio, like maximum distance? It's essentially the same distance as you would find in Bluetooth. So it's roughly about, I'd say 100 feet before you start getting a little sketchy. So if you've ever used those wireless Bluetooth speakers and you, with your cell phone, and you've walked out of the room with the cell phone in your pocket and the speakers starts coming out, it's about can you say it again? Okay. So the question, there's a glove that works with the Microbit. Are we planning on working with it and teaching around it? And I actually personally haven't seen it yet. Have you?
No.
No? So it's something that I'm going to get off of here and look up really quickly. But we'll look into it. But we don't have any plans with it right now. So what kind of power is required for servos and motors? The Microbit on its own, I'm going to pull it out here. I can actually hook up a servo using a battery pack and the Microbit on its own. And I can run a small hobby servo off of a couple AA or AAA batteries. Okay, right? I'm not going to get an optimal servo control. Most servos need 5 volts and up. You're going to get about 3 volts out of this AA or AAA battery system. That's where either the Gator Bit system or the Gator Bit is, because we actually can externally power this, or the Moto Bit. So the Moto Bit can control, I think, 3 servos and 2 motors.
Derek, can you touch on what a servo is for some teachers who may not know what it is?
So a servo is a smart motor that it travels only 180 degrees for the most part. Some of them are continuous rotation, but some are just 0 to 180. And instead of either turning it on or off, we give it a degree. So I can say 90 degrees, and that motor will turn to 90 and just stay there. And so that's a really good way to, if I want something to turn a specific number of degrees when the temperature is warm or cold, I can do that, or animate something. If you've ever used a remote control car, the steering in an RC car is a servo. Also, the speedometer in your car is a servo. So they correlate 60 degrees to about, or 60 miles per hour to about 35 degrees, and it works that way. Best power supply. Depends on the installation. If it is just basic lights and things like that, it's going to be the battery pack that hooks to the JST connector on the back of the microbit. If you're adding a lot of external hardware to it, the Gator Bit has a barrel jack that allows you to power it via a wall wart, a power supply that plugs into the wall, or a USB connector that does the same thing. It will take up to, it takes up to 9 volts technically. So you can use a 9-volt battery with it and things like that if you're using the Gator Bit itself. The microbit on it by itself is actually pretty sensitive to power beyond 3 to 5 volts. 5 volts through the USB jack, the USB port, that's what comes out of your computer. But if you're trying to use something beyond that with the JST connector with batteries, you have some dangers there with frying some circuitry. Rechargeable batteries. If they're AA or AAA rechargeable batteries, yes. Do not use lithium. They urge you to not use a LiPo battery, a lithium polymer battery that has a JST connector on it. Again, just really sensitive to the output of those. You may try it and it may work for a bit, but at some point it's going to drain that battery down and damage itself. That's it. I think for the last, we have about 10 minutes left. I'm going to do a quick demo of MakeCode on my screen. We'll talk you through things as I'm doing it. The great thing about MakeCode is that it has a simulator on it, so I don't have to have a microbit in front of the camera while I'm coding at the same time. But we're going to jump to my computer here and jump to MakeCode. So if you go to MakeCode, it's actually makecode.microbit.org. I'm going to click on a new project. As you can see, open, it saves your projects as cookies in your cookies of your browser. And so a short-term solution for saving files is actually it just shows up and just stays there. But I'm going to click on New Project. And I have a couple of different areas on my screen. I have my programming area where I build my program in blocks. My drawers, which are different. All of my programming blocks are sorted by functionality. So the basics, my input blocks, so on and so forth. Excuse me. And then a simulator on the left-hand side. So if I wanted to get started with using the microbit, one of the first things we do is how do we use that horrible 5 or 25 pixel display? How do I make a piece of art? So I'm going to click on Basics, and I'm going to use the Show LEDs block, and I'm going to drag that into Forever. And now I can turn LEDs on and off. So I can create a wonderful self-portrait of myself. Smiley face, and you'll see in the simulator here it'll show up. I get a smiley face on the simulator. The next step for this is building an animation. And an animation is nothing but one image shown right after the other. So I'm going to go to Basics. I'm going to bring in Show LEDs again. Drag and drop it. And notice that both of these blocks are here inside of the forever loop. And now I can create an open mouth, and now I keep talking to you like I am today, or I'm laughing maybe. Question is, how do I get this code onto my microbit? I actually end up going through a process of downloading this file to my computer and then dragging and dropping it onto my microbit. We're not going to demo this for you here. We have a number of other videos that kind of show you the process of our getting started videos that we can point to, maybe the link in the comments. But for now, this is a really good way to get started. And students love that pixel art. Ever since the dawn of Minecraft, it's all about pixel art in the classroom. And so this is one of those first steps of getting students going. And you'll just let them go, and they'll actually create pixel art all day long on the Microbit with 25 pixels. So there's that. And we can actually bring in some interesting inputs as well. So if I wanted to have something happen when I press a button, so there's button events. So if I have a button A, when button A is pressed, again, I can have it show, let's say, an icon. Instead of a heart, let's pick, Shelby, why don't you pick an icon?
Giraffe.
Giraffe, my favorite. And then I'm going to say when button B is pressed, I'm going to pick one. And I'm going to pick my favorite, the skull. So now, and if I go over to the simulator, when the program loads, if I press the A button, the giraffe shows up. If I press the B button, the skull shows up. And the best way to do this is, like, if I want this to clear, we all know an etch, or most of us know what an Etch-a-Sketch is, right? For me to delete or erase something on an Etch-a-Sketch, I have to shake. So I go shake, and then I'm looking for a block called clear screen. I'm going to click on more, clear screen. So now in the simulator, if I hit the A button, giraffe, B button, skull, and then I can move my mouse back and forth to shake it, and it'll clear. So again, really some basic inputs and a way to output some information on the Microbit. In fact, I'm going to leave you with one last thing and say show string, and I'm going to type thank you, and it should show up here. Thank you. And last but not least, one more thing I want to show you, just because Shelby whispered it in my ear, is so MakeCode starts off in blocks. So as you've seen, many of you, if you've used Scratch before, you're familiar with programming in blocks. But if I click on JavaScript up here at the top, it will actually take my block program and change it to JavaScript. And I can now actually, if I want to change this, I can actually start programming in JavaScript. Show string, low, and button A press. If I go back to blocks, whatever I changed in text now is updated here in the blocks. So I can work back and forth, and treat this as training wheels for coding and programming with the Microbit. So it's a really good way to transition students over to that. With that, I think we have a couple more questions. So
great question.
One of the ways, question was, is there a, sorry, I keep forgetting to do this. Is there an educator account so that I can track my students' work in MakeCode? One of this, it's a strength, but also a weakness with MakeCode is that there is no way to, there's no signups or no accounts for students. So they just start programming, and that saves us and saves teachers from having to get it okayed by their district and making sure that all the personal information and account signups and all that stuff is safe. But what it also makes tricky is that saving those programs that students make. And a number of ways to do that. We can actually, students can share their work and email you a link, or put that link in a Google Doc if they're reflecting. That's actually how Adam's 12 5-stars does it, is that the students in Google Docs have a journal entry, and they actually will take a screenshot or add the link of their code into that, so that the teacher can click on it and open it in front of them. But that again, strength and downside of things is that there's not a lot of classroom management that I can do in the code. Another question. Google Drive or Google Classroom. So how do I integrate these things? When I download, or when you download a file, it's a .hex file from MakeCode. You can actually save that to Google Drive. And for students to open that again, they can actually take that and drag that again back into MakeCode, and we'll open up their program, that saved program. So they can use Google Drive just like you would any other hard drive. It's just that you then have to import it back into MakeCode. We talked a little bit about Adam's 12 5-star schools, their way they do it in terms of using it as a journal entry, using the screenshots, things like that. As a teacher, if you're using Google Sites to share out or give assignments to your students, there's a way to actually embed code into your Google site, and I can show you that really quickly if you want to. Well, can we switch really quickly so that I can talk about this and show it at the same time. So for this, up here, there's the universal share icon. So if I had this wonderful program, if I wanted to share this with my students, I can click share, and it asks me to publish the project.
I can publish it. So now it gives me a link that I can share with my students. If I am a tech-savvy teacher that may have my own website, if I click on embed, I can actually embed the code here. So I can take this piece of HTML and I can copy and paste it into my website. I can even do that with a whole editor window. So if I want my students to play around with it and change things, they can do that there. If I want to just show that simulator window, I can do that as well. So all three of these are different options that I can pick and choose from to share out my code in different ways. I hope that answered that question. So, in terms of, the question was, what does the durability of the Microbit look like? Talk to that a little bit.
They're pretty durable in the classroom. The back can be a little sensitive because obviously that's where all the technology, fun sensors and boards and circuits are. We have seen some students kind of chip things off the back. But in terms of durability, they're pretty durable. There are cases out there, so you can always test those out, see what works best for your school.
I'd say the weakest point is the battery connector. When we have a battery pack connected to it, students like to do this, or pick things up and even try to unplug this by the wire, using the wire. And this JST, this connector is not designed, it's designed to be plugged in and stay there semi-permanently. And so when you want to undo the battery pack, we recommend using pliers or needle nose pliers and being ginger with it, because it's not designed to be plugged and unplugged a whole bunch. And so that's probably the one weakest, or I'd say the weakest failure point for the board. But then again, even if this connector came off, the board itself isn't bad. It's just that I can't hook up a battery to it anymore. Next question. Okay. That's it. Well, thank you so much for an hour of your time in joining us online. If you have any questions, feel free to email either Shelby or I, and our email addresses are on those front slides. And I will pull it up again here.
Yeah, and we hope that you saw some ideas today, really sparked some, creativity. Really want you guys to feel comfortable making the move and bringing this into your district.
So however we can help and support you, please let us know. That's what we are here for.
Mm-hmm. Perfect. Thank you very much.
Thanks again, everybody.
Bye.
Have a great